In this video, I'm going to walk you through lesson 1 of the unit C1 for Open SciEd. Now, before we begin, I have provided a link in the window below to the slideshow that I'm going to use to walk you through this lesson. I'm going to give you some links or show you some key slides and resources or handouts that are used in the lesson. So if you want to open the slideshow and follow along, feel free to do that. And also, I want to talk a little bit about what's on slide 2. Now, slide 2 provides kind of a flow chart of how this unit flows. And you can see that lesson set 1 covers lessons 1 through 4. It answers the question, how and why is sea level rising? So this really anchors the whole unit. We talk about climate change and CO2, and then it sets us up to think about, well, what can we do about this? And so lesson set 2 introduces 2 different solutions, and we're going to really investigate the first solution, which is the microbeads. And there's a transfer task at the end, which will have an assessment over all the big ideas developed so far. In lesson set 3, we're going to investigate more about that second solution, which is the berm solution. And we're going to, in lesson 12, take an individual assessment about the berm solution, and then a transfer task at the end, which would be lesson 13. And that is about a heat pump. So it's a transfer task. Now, I like to provide 2 things for teachers. One of them is the categories for the driving question board. Now, I'll talk a little bit more about this when we go through lesson 1, but teachers are often concerned and nervous if the questions that students will ask are not going to pertain to the unit, or they're not going to drive the learning and drive to the lessons that are in this unit. And so I like to provide some categories that you know will be covered to help you develop that driving question board. Now, the first one would be cause of sea level rise. Heat and energy is a good one. That one's actually, I find, a little bit harder to get questions about, but that is one that definitely will be needed. Carbon dioxide, that one's easy to get questions about. What can we do? Students often ask that. And then climate change as a whole. I will show you when we go through lesson 1 how these categories connect to each of the lesson sets. But if you are creating a driving question board and you're trying to categorize the questions, it's kind of good to know the categories. So this is a resource for you. And then the summative assessments, I walked through already the transfer task opportunities, but there are also 2 exit tickets that are considered summative. You can beef them up if you want, but those would be lesson 4 and lesson 9. So here's your really big summative assessment opportunities in the unit. Okay, let's go ahead and get started with lesson set 1, all about why and how is the sea level rising. And we're going to take a quick walk through lesson 1. If this is your first time implementing an Open SciEd unit, expect to go a little longer than this. I would say about 4 days if it says 3. This is the lesson, or the first 2 lessons here, since they're both considered anchoring phenomenon, that you want to really spend the time developing students' curiosity and eliciting student questions and motivating the need for the entire unit. So if you're going to trim anywhere, let it be later in the unit, not here at the start, because everything connects back to this starting anchoring phenomenon at the beginning of the unit. Okay, so we start by exploring 3 different communities, and they're all experiencing sea level rise. Here is the slide that goes with this, and you will see that it prompts students to set up a notice and wonder chart. They're going to watch 3 videos. They're going to write down what they notice on this side of the paper and what they wonder on this side of the paper. And there's also transcripts you can hand out to go along with this if students need a little support. There are some accents that might be hard to understand, so the transcripts could be helpful. But we look at a community in Louisiana, and they have been displaced by the flooding that's been happening. And then 2 in Africa. The first one is in Senegal, and the second one is in Sierra Leone. So we connect to these communities. We write down what we notice and wonder all about this flooding that keeps happening in their area due to sea level rise. And then we're going to go ahead and discuss our observations, and we're going to record them on a notice and wonder chart for the whole class. Now, this is something I really want to point out. These are key ideas. They're call outs in the teacher edition. They really help you facilitate a discussion, and they help you know what to listen for. And so this is really an initial ideas discussion, pretty easy to facilitate, but we're really building that momentum and excitement. And we're listening for ideas about sea level rise, how it's negatively happening or affecting people, climate change, issues like erosion, and this may actually be something that some of your students have experienced. And then we're going to record this on a Notice and Wonder chart. You can see comes from a professional learning event that I did. This is what teachers provided in student hats. So they're acting like students as a chemistry student. And so this is kind of what they noticed in the video. And then these are some of the questions that they were considering. And then we are going to talk about, and this is a partner share and talk, a turn and talk. And they're going to make a prediction about what ways might the challenges these communities are facing be shared by other communities around the world. So we're broadening what's happening in these three places to other communities, especially if they're in a place that has flooded or experienced sea level changes. Where do we think this is going to happen? So we do a little predicting, and then we look at a graph that has some historical data. And we look at and we learn a little bit about how the data was collected from 1900 till current time. It's using a tide gauge, and so that's described in the slideshow. And then satellite data begins around 1990, and you can see that the satellite data is very aligned to the tide gauge data. So we know that if this is accurate, this is going to be accurate as well. And we can see that the sea level change is absolutely rising. And so we talk a little bit about what we predict will happen in 20 years from now. How is that going to affect people? And that moves us into using the NASA Sea Level Project tool. And this is a pretty cool simulation. And you're going to go ahead and you can do this as a class and project it on the board and kind of have the whole class work on this together, or you can give it to students to look at by themselves. But if you, I'm going to go over here to the United States, and if I zoom in a little bit and I pick an area, I live in Southern California, so we did this with our teachers, and we were pretty. It was interesting to see what the local effects would be. I'm just going to click on this one right here, which is Port San Luis. And you can see that in the year 2100, it's going to be 0.52 meters above current sea level. And so that's how much it'll rise. You can make adjustments over here, but this is a fun tool to kind of just see how the sea level rise is going to affect communities around the globe. And then we talk about the impacts on community and examine community responses. And what this kind of leads to is the idea that communities all deal with this very differently. There might be some inequity, there might be some ideas that are in one place and not another, but it definitely is handled very differently across the globe. And so we read an article, it's called Climate Change Terminology. And the reason we read this is that often the term refugee has some negative connotation to it. And so we just bring this to the surface, we talk about it, and then you're going to define what you want to call people who are displaced by climate change or sea level rise in your classroom to try to take that negative connotation away. And so one term that's suggested is climate migrant, but you can develop this with your class and determine the term that you all want to use that's respectful to the people that are being displaced. And then we're going to explore some related phenomena. This is a slide. We do not make a poster in this one, but we do talk about where we can see these types of features on Earth. And so this can bring up experiences that students have had. Maybe they visited Alaska, or they have visited a lake, or they've seen a river. But this is kind of leading to the idea that there is ice in the ocean and there's ice on the land. And so maybe this ice is melting, and that we're kind of going to lead into that direction to help us develop some initial models. Now, this is the initial model handout that students will get. There's a couple questions. Where do you think the water is coming from? Where do you think the water that causes sea level rise, how does it get to the ocean? So we're trying to get a lens going of where's this water coming from? How's it getting to the ocean? Okay, now let's draw it. And so they draw the components, including ocean water. They have symbols and arrows. This is really a scaffold of and a reminder of what's in a model. And then they talk about what's happening at the particle level. So we're forcing students to think about chemistry here and how the particles are interacting to be a part of explaining sea level rise. And so then we share actually using concentric circles. If you've never done that before, it's described in the teacher edition where you have a group of students in a circle and they face outward, and then another group on the outside and they face inward. So you share your model with the person you're across from. And you can share with several different partners. We're looking for similarities and differences. We're also getting ready to create a class consensus model. And when we do that, we're looking for where we agree and disagree. That concentric circle, or just even sharing with a partner your model, helps provide some a little bit of safety for students to say, oh yeah, I thought that too. So now they feel safe in sharing that because they both had it in their models. So it's a scaffold to share with another student and feel really safe about sharing ideas. And if it's not their idea, they can say, well, my partner did this. And so now that's even safer to share because you're not scared that you're going to be wrong. It takes a minute for students to feel safe sharing. You need to build your community agreements and create that safe culture, but also just to know that the experience of sharing and it is not right or wrong, that they need to experience it. And it was okay to share. And so the more they experience it, the more willing they are to share. And so we come to an agreement, and as we're doing the consensus model on what we define as a system. And so this should be a review for chemistry students, but it's going to talk about what's going in to our system, what's going out of our system. So inputs and outputs, we're creating that lens of matter and energy. And we think about like systems do we care about that are contributing to sea level rise? The ocean system, the rivers and the land water. So we kind of figure out that all of these earth systems are together contributing to sea level rise. Here's a sample from a professional learning event that I did, and notice that there are two things. Mine looks nothing like the teacher edition. That is okay. It doesn't, you need to draw what people are sharing with you. And so I have, the glacier was melting onto the land. I asked, what did this look like at the particle level? So I drew this and I said, how do I draw these as dots? Okay, like this. Okay. How did you show they were moving? Oh, I had little arrows. Okay, like this. Great. Now notice I have some question marks. I'm really trying to get the question marks on the consensus model by saying, does everybody agree with this? Who is not sure? Or who disagrees? And if anybody raises their hand and is unsure or disagrees, I mark it with a question mark. So you notice I have a question mark here. I've got a question mark here. And so I'm showing that we don't totally understand this, that we've got some things to figure out. And so I'm always trying to get question marks on my consensus model. You can see that we talked a little bit about how CO2 is getting into the atmosphere and that carbon cycle. So whatever they say, you share. Now, the teacher edition does give you a lot of guidance on how to walk through students and building this consensus model, which will also lead to the definition of system and then an energy transfer diagram. This is the very beginning of my energy transfer diagrams. My sun, I know it doesn't look like a sun, but I've got a sun. Heat is coming off. That's what the participants told me to put in the arrow. And then this was in the system. Water, it's melting. There's rain. There's CO2. So the teacher edition will give you some guidance, but just do not worry if yours does not look like the teacher edition. You draw what they tell you to draw. Okay. We then ask some questions. Now, those questions on the consensus model are helpful. Remember, there was also a notice and wonder chart. So we look at those questions and we then write them down on sticky notes to create a driving question board. Now, I will say there's only one question per sticky note. If you have a large class, this can be a huge lift. And so I have changed this with really big groups where I don't have every student write 3 or 5 questions on a sticky note. That's just too many questions. So what I do is I put them into groups. I have them share their questions with the small group, and then the group decides on their top 3 priority questions that they think will help answer the anchoring phenomenon, or they think we can investigate to help explain the anchoring phenomenon. And so then I get just 3 questions per group. And so then I put them on the driving question board, and it looks like this. Now, I talked earlier about the categories. Here are the 4 categories. Actually, only 3 came up in my event. We did not have a large group. So with more people, hopefully we would have gotten some questions about heat and energy. Now, do not worry if your driving question board does not have one of these categories. You can always add a question later on if you hear it come up in a small group, or if you hear somebody ask something at any point in the lesson, you can say, hey, that's an interesting question that might help us solve the anchoring phenomenon. Why don't you document and put that on the driving question board? So at any point in the unit, you can add to the driving question board. You can also add a category called other. So if nothing really fits or relates to anybody else's questions, you don't want to not put it on there. You want to value the question, but just create a category called other, which you may or may not get to. You will reflect on the driving question board at the end of the unit. But you can see that these are the lessons. Lesson 4, we answered this. Lessons 2 and 3, we talked about carbon dioxide. 5, 6, and 8, all solutions. Heat and energy, that is your second lesson set. So what I like to do is I say, who would like to start us off with our first question? And let's say someone asks me a question about the cause of sea level rise. And then I am holding that sticky note, this one right here, and I say, okay, who else has a question similar to this or that relates to this? And I have them read their question, and I go around and I collect their sticky note. And then I have them read their question, and I collect their sticky note. Then I walk to the board and I put all of these sticky notes down, and I label it cause of sea level rise. I say, well, these all seem to really be about the cause of sea level rise, and I write down the category. This is important because some of the driving question board directions ask students to come up with the categories, and that is a really heavy lift. So I like to control this a little bit more, knowing that this is going to be answered in the storyline. So I want my category there. I just control it more this way. Once I'm done and nobody has any more questions to contribute to this category, I say, who would like to start us off next? And so someone reads something about what can we do? How can we reverse global warming? So I say, does anyone else have a question about something we can do or how we can help mitigate this or solve this problem? And I have everybody read their questions. I collect their sticky notes, and I bring it to the board, stick it on the board, and put the category. So hopefully that's helpful in understanding how I control a driving question board. If you have a really well-behaved class and it's easy to manage, you can have students facilitate this. You can have them walk to the board and put their sticky notes. You can have them categorize and remove all the sticky notes around, but that is really chaotic. And if you are new to driving question boards and your students are new to driving question boards, I've given you a suggestion on how to kind of control that chaos a little bit more. All right, we end our lesson 1 with a list of ideas for investigations. Now, you can actually give each group, if you want to break them up into small groups again, a category from the driving question board, and then they brainstorm investigations for their category. So that helps have like more diversity in ideas for investigations. Here's a sample. I did not do this. It was a small group. They talked about we could test how different amounts of carbon dioxide under a heat lamp. Could we do this? We can exhale into a bottle. Well, actually, this is going to happen in lesson 3, not exhaling, but with Alka-Seltzer tablets. We can watch videos. This happens. Often you will find what students suggest actually does happen in the unit. Now, you don't have to do them just because it's on the list. What we're doing is showing that their ideas are the same ideas that scientists have. It's the same process that scientists go through to help figuring out how to explain an anchoring phenomenon. Okay, so that is the anchoring phenomenon routine. Although we've gone through all four elements, we're going to develop a little bit more of this in lesson 2 about climate change. But really, we've gone through all the steps of the anchoring phenomenon routine, and we're ready to start investigating and figuring out why this is happening and what we can do.